Okay, hi everyone. In the last lesson, we covered Genfarmer basics, managing your Acumizer account and running a mini app.
Today we'll dive into Genfarmer nodes and how to build a simpler workflow. First, look at the left sidebar. This is where you choose the device you want to control. For example, select EMPH device number 1, click it to open view and see the device panel, so it's easier to operate. Next is search. Use it to find nodes quickly. Below that, nodes are grouped into folders. For example, data contains nodes for data-related tasks. To add a node, just click it. If you already know the node name, search here to add it faster. To make this clearer, I've laid out all nodes by category, from basic to advanced. Before we start, let's look at Inspector. Just like on the web, you capture paths. On mobile, you also need accurate paths so your workflow can run. In Inspector, first choose the device you're working on. Here, I'm using device number 1. Then use the element Picker. Click something like Chrome to capture the path you need. Reload refreshes the inspector when your screen changes. For example, if you navigate on the phone, Inspector may stay on the old screen. Tap Reload to sync it. For image-based handling, use Toastmate. If you don't have a background XPath, it can copy the current image for later steps. In later lessons, image processing nodes will use the image saved here. This panel also shows each element and its attributes, so it's easier to verify and back up paths. Now, let's go through the JSummer nodes. We'll start with the core automation group, nodes that interact with the UI like human touches. First is Press Button. It works like the back button, returning to the previous screen. Next is Press Home. It takes you straight to the home screen without tapping on the device. Next is the Press Menu button. It's like opening the menu flash to recent apps view, so instead of doing it by hand, you trigger it here. Next is the node that lets you tap elements on the screen. To use it, we'll go back to the inspector interface. Example, if I want to open this control, I'll go to Inspector and select that element. Then I copy the XPath line, paste it into the XPath field, choose Tap by Selector and run it. It will tap that element automatically. The second way is tapping by coordinates. Grab the element's coordinates in Inspector, paste them in, and test. So it opens this control. Here you also have timeout. If it can't find the element within, say 10 seconds, like when the UI changes and the element disappears, it will stop and throw an error. Next is tap mode. Default is single tap, but you can switch to options like double tap or tap by text. In settings, there are 2 items. First is the wait time, e.g., set 5 seconds, it will wait 5 seconds before tapping. This applies to the nodes after it too. Next is drop label. Whatever name you set here will show up in the log, so it's easier to manage. You can also name the node so it shows on hover. So that's the tap node. Next is the node for swipe actions. There are basic swipes, down, up, left, right. For example, choose up and run. It will swipe up by a fixed distance. Then there's custom. You swipe based on coordinates and speed, set a start point and an end point, get both coordinates from Inspector, and it will swipe from point A to point B. That covers the swipe node. Next is the node for typing input. First, select the element you want to type into, then enter your text, like composing a message.
For sending input to a mobile target, first choose the element you want to type into. Then enter the value you want inside this text box. For example, I'll take the value I need, like a password or a preset text, paste it here, and fill in the data I want to input. In the To Check section, there are 2 modes. Mode 1 is autofill. It inserts the text instantly. Mode 2 is type, typing like a human. Select type, then adjust the typing speed. For example, I'll set it to 2 so you can see the difference. It will type automatically at that speed. If you're working on stricter platforms, enable human-like typing to reduce the chance of being flagged. Next are the small system buttons. Instead of tapping system buttons manually, like opening the camera or muting, this node can handle those actions. For example, I'll press volume up. When I run it, the volume increases by 1 step. Next is the screenshot node. You need to set the file name, the format, image, and the folder to save it in. For example, I'll choose a folder like Genfarmer. When it saves the screenshot, it also returns an image variable in base64 format. So I'll store it in a variable like image_base64. It also returns another variable for the image size. You can create a variable to store that as well. After you run it, it saves the screenshot to the folder you set up and returns the image size plus the base64 image data. So those are the nodes for device navigation and UI interaction. Next, we'll move to the second group of nodes. These help ensure the tool is running in the correct environment, right app, right state, and right device. This group is called App and Device Management. The first node is Startup. Instead of tapping Chrome to open it manually, Startup can launch the app directly without needing XPath for navigation. To launch it directly, you need the app's market name. So I'll open Chrome first, then go back to Inspector to get its market name, scroll down to the market name attribute and copy it.
Next, go back to the startup node. Tap here. Now you can launch Chrome directly, without navigating to the screen and tapping it manually. For example, I'll go back to the home screen and swipe so Chrome is no longer on screen. Then I use Startup to launch it. It will open the app automatically. Similarly, Stop will close the app. Just paste the package name, then run. Next is the node that checks whether the device has the app installed. Paste the package name and run. If it's installed, it outputs installed. If not, it outputs not installed. To test the not installed case, we'll install an app first. To install an app, you need an APK file. You can download it online. I've prepared a Facebook APK. This device doesn't have Facebook installed yet. Open the install node, then select the APK file. Now click Run. It will install Facebook automatically. When it finishes, Facebook will be installed on this device. Before running any workflow, you can use these two nodes. Check if the app is installed, and if not, install it. Just provide the APK file. To check again, we need the package name. So we'll go to Inspector and grab it from the app info. Here's Facebook's package name. Copy it and paste it into the check node. Next, I'll uninstall it to test removal. Paste the package name into the uninstall node and run. After it completes, Facebook disappears from the device. Now, run the flow again. It checks not installed, then installs Facebook automatically. That's a simple flow. Check first, then install if needed. If it's already installed, you can continue with the next tap steps. Next is the node to clear an app's data. For example, to clear Facebook data, paste its package name and run. It will wipe the app data automatically.
For example, if an account gets banned and you want a clean reset, use this node to clear everything before logging in with a new account. Next is the node for changing device info. It has two options. 1. Change the device info, or 2. Reset it back to the default profile. Use whichever fits your needs. When you run it, it will automatically spoof the device as another device profile. Next is the node for managing device services. For example, airplane mode, Wi-Fi, 3G, or turning everything off. Choose the option you want, run it, and it will do it automatically. Next is checking the device state. There are 3 states, but you mainly care about this one. It tells you which app is currently running. So if you launch an app and want to make sure it's fully open before running the next steps, you use this node. Now we'll move to the next group. This group makes your workflow smarter. It can branch and run different actions based on conditions. I call this group logic control and processing. The first node here is random. If you run the same logic across many devices, it's easier to detect behavior patterns, so you use this node to randomize variables. For example, in account scanning workflows, you can randomize emails, paths, names, or even numbers. Then you use that random number to choose a branch. Example, output a variable like flow. If it returns 1, run branch 1. If it returns 2, run branch 2. Let's test it. When I click Run, it returns a random value from 1 to 5. If you want to randomize email for account checks, choose Email. Each run will output a different email address. It can also generate different passwords, so you can use them for web apps and similar tasks. Next is the Compare node. You use it to compare a variable by logic, greater than, less than, equal, or not equal. For example, I'll set the flow variable to 3, then combine it with the random output. If the random flow equals 3, we run branch 3. Otherwise, we run a different branch, depending on what you need. That's just an example. When the random value hits the condition, it triggers the matching branch automatically. If the random value is 2, it won't match 3, so it returns a fail output. Then you handle the next branch. Next is the multi-case node. It basically combines multiple compare checks into one. Instead of chaining 2 compare nodes, check equals 3, and if not, check equals 2, you use this single node to keep the workflow cleaner. Example, we check whether the workflow variable equals 3. If it equals 3, it runs that branch. If it equals 2, it runs the branch below. If the random result is 1, it matches none of the cases, so it goes to the default output so you know it didn't match. To make it easier to verify, I'll use a log node. If the output equals 3, it triggers the log and prints equals 3. Next is the loop node. This lets you repeat actions based on a condition. These two loop nodes work similarly, but we usually use loop v2, so I'll focus on loop v2. Loop v2 has 2 parts, start and end. They're linked together by a loop ID. You can keep the default loop ID or rename it by task for easier management. For example, if this loop is for checking accounts, name the loop ID something like check account. Next is the grid node. It has 2 main roles. By default, it jumps back to continue the loop, but if you connect it to stop loop, then when it hits this node, it stops the loop immediately. I usually place stop loop in the matched branch, so once the condition is met, the loop ends right away. Now let's talk about the first loop pattern. This one is for a fixed number of iterations. If you know you want to run something n times, 3, 5, or 7, you set the loop count and run it. Example, we'll run it 5 times. Each time we randomize and check whether it becomes 2 or 3. Now I run the loop. It runs 5 times, and in this run, we got 3 once. If it never hits 3, then all cases will fail. Next, I'll try 4 runs to compare. And when it hits the value 3 once, that's the end loop feature. When you use this loop type with a fixed count, it runs tasks where you already know how many times to repeat. For example, post 10 times, watch a video 5 times, or retry a login a set number of times when it fails. Next is looping with a condition. This means you keep looping until your condition is true or false. When you don't know the number of repeats in advance, use this. For example, loop until a variable matches your target value. You also have other conditions like less than, greater than, equal, not equal, and so on. Another loop type is looping through data. You run once for each item in a list, like a list of accounts, content, or values. For example, if you want to post each item in a list, you put all posts into a variable and run it. Or if you want to message every user in a list, you paste the user list here and loop through it. It keeps running until the list runs out of data, then it stops. That's the data loop feature. In later lessons, when we build real workflows, I'll demonstrate these features in practice. If you have a real use case you want me to do, leave a comment. Next is the sleep delay node. It pauses for a time you choose, like 5 or 7 seconds after finishing a step. If you want a random pause instead of a fixed one, switch to random mode, e.g., pause randomly from 5 to 7 seconds. Next is reconnect. If your device errors out or loses connection, this node reconnects automatically. Next is command. It lets you add notes/labels to the branches you've built, so it's easier to understand, maintain, and upgrade your workflow. For example, I use it to label each node group so viewers can follow along faster. Next is the group for detection and validation, checking whether an element exists on the screen. The first node is XPath, which is commonly used to check the current state before performing actions, like clicking a specific button. To know whether we can click a button, we need to check its clickable attribute. If it's still loading, you may not be able to click. If you click without knowing whether it worked, the workflow can break. So in these cases, we use the XPath node to check first. To use it, grab the XPath of the element you want to check. For example, this button, copy its XPath line and paste it here. Then choose the clickable attribute and pick a variable to store the result. You can store it in any variable. I'll store it in flow to test. When you run it, it returns true because this button is clickable right now. Next is element exists. It checks whether an element is currently visible on the screen. For example, copy the element's XPath and paste it in. If you're on the correct screen, it will report that the element was found. If you're on a different screen, it keeps scanning until the timeout. Here my timeout is 30 seconds. If it still can't find it, it throws an error. For example, I run it while the element isn't on screen. It keeps scanning. When I swipe back to the Tron screen and it appears, it returns success. Then we continue the next steps. The multi-element exists node is similar, but it can check multiple elements at the same time. For example, we can detect which screen we're on. One element for Play Store and one for Tron. Instead of using 2 separate checks, this scans both at once. So we add Tron elements here, like the Tron password field, and add the Play Store element on the other side. Then run it, and it tells you which screen is active. To make it clearer, we can connect each result to a log node. If it's Play Store, it logs that branch. If it's Tron, it logs that branch. When you run it, it scans automatically and tells you you're on the Play Store. If you're on the other screen, it will tell you you're in Chrome. Basically, this node is multiple element exists checks combined into one. Use it when you want to detect which screen you're on, then handle the right branch faster. This is what Element Compose is for. Next is image-based search. In Inspector, there's an image section. If you can't capture the XPath, you can use image matching instead. For example, we'll scan using this phone image. Paste the image data, base 64, here, and it will load like this. Then you need to set a few properties. First is the wait time, how long to wait for the image to appear. Set 5 seconds, 10 seconds, depending on your needs. Next is action. If you only want to check whether it exists, choose Do Nothing. If you want to click the matched image, choose Click. Next is the similarity threshold. The higher it is, closer to 1.0, the closer the match must be. If you set it to 1.0, it needs to be a 100% match to return true. Even small differences, colors and details can make it return false. So a typical setting is around 70% or 0.7. Next is the comparison method. There are different recognition algorithms, different ways to match the template image to what's on screen. Here we're using pixel-based matching, which is usually faster and more accurate. Next is which match to click. If you leave it empty, it clicks the first match it finds. If there are multiple matches, enter the index you want to click. Next is click delay. By default, there's no delay, but you can enter a delay in seconds. Finally, output can return the coordinates where the image was found. You can store it in a variable if you want. For example, set wait time to 5 seconds. When you run it, it waits, clicks the image, then returns the click coordinates.
All right, that's everything for today. In the next session, we'll learn the node groups for data management, network management, and nodes that integrate AI into your workflow. See you in the next video.